Something extraordinary may be buried beneath the Martian sands. Something that could change everything we thought we knew about the red planet. For decades, Mars has been painted as a barren wasteland, a cold desert world that lost its chance at life billions of years ago. But now, beneath the dust and dunes, new evidence has emerged that hints at a very different past. A past where waves once crashed on Martian shores, where the northern plains were an endless desert but a vast ocean. And the discovery comes not from NASA, but from a bold newcomer to interplanetary exploration. China's first rover, Zhurong. When the first images and radar scans came back, scientists were stunned. Hidden under the surface, the rover found unmistakable signs of a buried beach sediments, shaped by waves, layered over millions of years. It wasn't speculation or guesswork. It was direct, physical evidence that Mars may have once been home to oceans. And if oceans existed, then the possibility of life is no longer just a dream. It becomes a very real question. But to understand how this discovery was even possible, we have to go back to the moment China made its daring leap into the unknown. In July 2020, while the world's attention was focused on a global pandemic, China quietly prepared for one of the riskiest space missions ever attempted. They weren't content with sending just an orbiter to Mars. Instead, they packed 3 missions into one: an orbiter, a lander, and a rover. It was an all-or-nothing gamble because no country had ever pulled off such a feat on its very first attempt. The mission was called Tianwen-1, meaning Heavenly Questions. And those questions were clear. Could China not only reach Mars but also land on it and explore its surface all in one mission? After a 290 million-mile journey, Tianwen-1 slipped into Mars's orbit in February 2021. But the real challenge was still ahead. Only a handful of spacecraft had ever survived the 7 minutes of terror, the fiery plunge through Mars's thin atmosphere. In May 2021, the lander descended toward the surface, aiming for a region called Utopia Planitia. To the outside world, this flat plain looked unremarkable. But for decades, NASA data had hinted that something unusual was hidden there, perhaps even a massive underground reservoir of ice stretching across an area the size of Lake Superior. The landing succeeded, and for the first time, China had placed a rover on Mars. The 6-wheeled machine was named Zhurong. Unlike NASA's high-profile landings, complete with live streams and global fanfare, China marked the achievement with quiet pride. The rover simply rolled off the lander and got to work, almost unnoticed by much of the world. But this modest beginning would soon lead to one of the most important discoveries in Mars exploration. On the surface, Utopia Planitia looks calm and empty, a dusty plain stretching endlessly in all directions. But planetary scientists had long suspected there was more to it. This region is part of the largest known impact basin on Mars, a depression so vast that if it were filled with water, it could hold an entire ocean. Orbital maps revealed strange ridges and slopes that some scientists believed were ancient shorelines, clues that an ocean might have once covered Mars's northern hemisphere. But those were only theories. There was no hard proof, no direct evidence that could confirm the idea. That's why Zhurong's landing site wasn't chosen at random. China targeted Utopia Planitia for its scientific potential. If Mars once had a true ocean, this was the place to find its traces. Fortunately, Zhurong wasn't just equipped with cameras and soil analyzers. It carried a powerful tool rarely used on other planets: ground-penetrating radar. This instrument could send radio waves deep into the Martian soil, bouncing signals back to reveal hidden layers underground. It was the perfect technology to search for something as elusive as a buried beach. And as the rover rolled forward, it approached a steep ridge rising from the plain, a formation that geologists had whispered about for years. Some thought it might be nothing more than a random hill. Others suspected it was the edge of a long-vanished shoreline. Now, for the first time, a rover was there to test the theory. Zhurong began scanning the soil beneath its wheels. Day after day, its radar pierced the ground, mapping layers that had been hidden for billions of years. And then, just 33 feet below the surface, the signals revealed something extraordinary. There, stretching for miles, were smooth, continuous layers of sediment, not random or chaotic, like dunes shaped by the wind, not jagged or shattered like rocks from a meteor strike. These layers sloped gently upward toward the ridge, exactly the pattern you'd expect to find along a shoreline shaped by waves. On Earth, coastal beaches form distinctive wedge-shaped layers of sand, building up gradually as waves push sediment toward land. The radar data showed that Mars had the same structure. The slope, the alignment, the texture, it all matched what geologists would recognize instantly as an ancient beach. For the first time, scientists weren't just speculating about oceans on Mars. They were looking at direct physical evidence of one. And that evidence was buried beneath the very spot Zhurong had been sent to explore. The implications were staggering. Mars wasn't always a dry, desolate world. It once had waves, tides, and long stretches of shoreline, just like Earth. And where there are stable oceans, there's the possibility of life. But the discovery raised another question. How long did these oceans last? Were they just brief floods that evaporated quickly? Or did Mars once host a true, long-lived sea? The answer lies in the thickness of those buried layers. Some were more than 100 feet deep, built up slowly over what must have been millions of years. This wasn't the signature of a short-lived flood or a temporary lake. It was the record of a stable, enduring ocean. To have such a long-standing body of water, Mars would have needed a very different environment than the one we see today. Its atmosphere must have been thicker, its climate warmer, and its skies perhaps less dusty. In short, Mars may once have looked far more like Earth than we ever imagined. And this is where the mystery deepens. Because if Mars had oceans that endured for millions of years, then the planet didn't just have water, it had time. Time for chemistry to unfold. Time for nutrients to accumulate in shallow coastal waters. Time for life to take hold. But oceans don't last forever. Something catastrophic must have happened to transform Mars from a blue planet into the cold desert we see today. Scientists believe the turning point came when Mars lost its magnetic field. Unlike Earth, which is protected by a strong magnetic shield, Mars's field collapsed billions of years ago. Without it, the solar winds stripped away the atmosphere piece by piece, thinning it until the oceans boiled away into space. What Zhurong uncovered wasn't just a beach, it was a graveyard of an ocean, a silent record of a world that once had all the ingredients for life, but then lost them. And here's the haunting thought. If life ever did emerge in those Martian oceans, what happened to it when the waters vanished? Did it die out completely? Or could something have adapted, retreating underground where pockets of water and warmth might still remain? This is where things get unsettling. The discovery of a buried shoreline doesn't just hint at water, it hints at habitability. On Earth, life thrives wherever there is liquid water, oceans, lakes, hydrothermal vents, even underground aquifers. If Mars once had a stable ocean that lasted millions of years, then microbial life would have had a real chance to appear. Some researchers argue it may have even flourished. The shallow coastal environments revealed by Zhurong's radar are exactly the kind of places where life first appeared on Earth. Warm, nutrient-rich waters, cycles of wet and dry, energy from sunlight and geothermal activity. These conditions are not just favorable, they are ideal. And if Mars once had life, then the question becomes, is it still there, hiding beneath the surface? For decades, missions have searched for direct biosignatures with no success. But perhaps we've been looking in the wrong places. Instead of ancient riverbeds or scattered rocks, maybe the answer lies beneath buried beaches, fossilized traces of microbial mats, preserved in the sand, waiting to be found. What makes Zhurong's discovery even more remarkable is how quietly it happened. NASA's rovers dominate headlines, but China's first Mars rover has already reshaped the debate about Martian oceans. Over the course of its mission, Zhurong traveled nearly 2 kilometers, collecting vast amounts of radar data. The rover has since gone silent, likely buried under seasonal dust storms, but its findings live on. They are a reminder that Mars is not owned by any single nation. The search for life is a global endeavor, and sometimes the greatest breakthroughs come from unexpected places. It's almost poetic. A newcomer to Mars exploration, operating in silence, uncovered some of the strongest evidence yet that Mars was once a living planet. If Mars once had oceans, what does that mean for the rest of the universe? For decades, astronomers have debated whether life is a cosmic accident or a common outcome wherever the right conditions exist. Mars is the ultimate test case. If a planet right next door once had oceans, atmosphere, and potentially life only to lose it, then the universe may be filled with worlds that briefly bloom with biology before fading into silence. Life may not be rare, it may be fragile. Think about that for a moment. In our galaxy alone, there are billions of planets in the habitable zone. Many may have oceans like ancient Mars. Many may even develop life. But how many survive long enough to evolve intelligence? Or are most civilizations erased before they even begin, just like Mars's lost ocean? Zhurong's discovery isn't just about Mars's past. It's a mirror, reflecting the possible future of Earth. The buried beach discovered by Zhurong is only the beginning. Future missions, perhaps from China, perhaps from NASA, or perhaps from a joint effort, will need to drill deeper, recover samples, and search directly for biosignatures. The most tantalizing target isn't just Utopia Planitia, it's the ancient northern lowlands as a whole. If Mars's ocean once covered them, then its shores may stretch for thousands of miles. Imagine the possibilities. Fossilized microorganisms trapped in sediment, chemical traces of organic life, or even frozen pockets of briny water still hiding beneath the surface. Each new mission now carries a sharper purpose. We're not just exploring a dead world. We're following the trail of an ancient ocean and maybe, just maybe, of life itself. For centuries, Mars has haunted our imagination. It was once thought to be home to canals and civilizations. Then, as science advanced, we stripped away those illusions, reducing Mars to nothing more than a cold rock. But Zhurong's quiet discovery has changed the story again. Beneath its dust, Mars still whispers of a time when it was alive. The buried beach is more than a geological feature. It's a memory of a lost ocean, a world that had warmth, water, and the ingredients of life, only to lose them all. It challenges us to rethink not just Mars, but the fragility of planets themselves. Earth is stable for now, but even here, oceans rise and fall, climates shift, magnetic fields weaken. Mars shows us what happens when a world can no longer protect itself. It becomes a graveyard, holding the fossils of what might have been. And yet, there's a deeper, more chilling possibility. If Mars had oceans, and if life once stirred within them, then the red planet may not be truly dead. Beneath the ice, in the dark underground, something may still linger, something that has waited for billions of years, hidden beneath the sands, beneath the buried beach. Perhaps one day we will dig deep enough to find it, and when we do, we may learn that life in the universe isn't rare at all. It's everywhere. But survival? Survival may be the true challenge. Because Mars tells us this: worlds can live, and worlds can die. And the question that remains is, how long will Earth's oceans last before our own world joins Mars in silence?